Starting, the topic for today is how to write the reliable code. And this is particularly important in C because the origin of C is related to operating systems. And operating systems is an environment where I need to access hardware directly. I need to read and write on hardware devices. And in that sense, it's very close to embedded programming because the situation is the same. In embedded programming, we need also to deal with hardware devices. And so this makes C a very powerful language. And also another feature is the syntax of C, which allows us to have very short sentences and to pack a lot of instructions in a single line. And this gives origin to lines like the ones that are written there, which even for people with some experience in C, some of them take some time to have a look at and understand what's really there. So as it said there, the C got the reputation of being what's called a write-only language because there are some programs that are difficult to read. And as a matter of fact, there's even one thing called the International Obfuscated C Code Contest, which is a competition for those who try to write the most critical possible C code. And in fact, the winners of the competition are people that succeeded in writing programs that looking at the code is fairly impossible to understand what's it doing. There's this a site with all the entries that you can have a look with from the previous years, and just to show you an example of what is this kind of competition, I would like to show you a favorite of mine, which is this Endo2 entry, which is you have here you can have here a short this description. It's a program that generates new programs. So the output of this program is another C program, and we will see what it does in a minute. I will demonstrate you how does it work. So you are seeing my desktop, right?
Yes.
Okay, so I have here the entry code is just a makefile and the original C source, and I'm going to show you the C source. This is the source code for this entry, or adding it with an editor. This is the source code. But this is a real source code because if I compile it, I get a normal program, and if I run that program, the output is another C program. Now instead of a tab, it has got a pi symbol. And now if I run this program, but store it in a file called pi.c, now I can also compile this one, and I can run the new program. Okay, and this new program is another C source file, but instead of drawing an ASCII with a pi symbol, it writes out the value of P, 3.14. And now this is also a C program that I can output to a file and then compile that file and again run this new program, and I have again 3.14, and now with another figure added, and every new compilation will generate a new C source file that will print in this way, and the next one will have 3.1415 and so on and so on. But all of this is valid C code. As you have seen, it compiles and runs. And so this means that we can make very strange things with C code. And there are a lot, this means that there are a lot of insecurities in C. And they have several sources. First of all, the programmer can make mistakes. What's the problem with that code in the first example?
50,000 doesn't fit in a 16-bit.
Yes, 50,000 doesn't fit in a 16-bit wide value. So this is kind of things that can happen very easily, and they may be hard to detect. We can make errors by using the language. What's in the bottom is another recurrent error in the C programming. When we are making conditionals, we use a single equal sign instead of the two equal signs for the comparison of operator. And other things like the programmer expecting one thing and the compiler reading it in a different way. Can you tell me what's the purpose of if you would meet this line in a C source file? What is the purpose of this line?
I think it's to make a pointer.
Yes.
But we need to do it like individually, int A and then int B, I think.
Yes.
Okay.
Okay, so int and star is a pointer to int.
Yes.
Right?
Mm-hmm.
So A is a pointer to an int and B.
I think the program doesn't know.
Is it a pointer to an int too? Or is it an int? Well, in this case, the operator, the star.
I think it's referring to A.
Yes, that's one of the particularities of C that we must not forget, is that this star here, it applies to A.
Yes, okay.
Okay, so it means that A is a pointer, but B is not a pointer. Although that when we are reading it, we might think that we are creating two pointers for A and B are both pointers, which is not how the C syntax defines it. So there are a lot of these situations that we must take care of, and it's very easy to make this kind of mistakes. And also the language, the compiler may contain errors. Compilers are software, so they can have bugs. And there are things like runtime errors. It means that everything in the language is right, but there is something that an error that only occurs when the program is running. So when we are writing code in C, we need to take great care in how we do it, because C is a powerful tool, is like a very sharp knife. It's very good to cut and to make precision cuts, but if we don't take care, it might get cut with a knife too.